This conference will now be recorded.
So guys, we're gonna understand what is CNN for the day. So let's begin with the convolutional neural networks in the deep learning environment. So convolutional neural networks, or CNN or Conv Net, right? As in we have different ways to take the same name. So they are going to enable the machines to view the world as humans do. So that is the major idea behind writing a CNN. The way you see an object, right? So same way, the algorithm can understand, okay, that this object is that. So typically, what happens, right? With your eyes, you are able to see one large image, and from that image, you are able to identify small objects. Based on that, you can make out, okay, that this is this thing or that thing. Now, for an example, if I'm seeing some human being, so I understand that there are eyes, nose, mouth, so I would be able to make out, okay, this is the face of a human versus the face of some animal, right? That's how we distinguish. So this convolutional neural network is majorly into image and even the recognition from the videos. So analysis and the classification on image, then recreating some media based on the learning path, recommendation systems, natural language processing, right? So these are some of you can say the applications where convolutional neural networks are used. So the advancements in the computer vision with deep learning is due to one of the algorithms called CNN, right? So even Google uses CNN approach to solve so many of the problems with respect to the vision. So guys, how image processing is seen when it comes to the neural networks, right? So neural network, the feed forward networks, which we have already seen, right? So there is one image here. You can see an image. So we are considering that, okay, it's a 3x3 image with some pixel values represented in some numbers, right? And we other way around know that an image is a matrix which is going to have pixel values in the RGB format, right? So we did it in our previous discussions, right? So guys, if we got this 3x3 image, we can convert it into a 9x1 vector, and we can say, okay, so we got this 0 to 8 features, feed it to the neural network, and let the neural network on the basis of these inputs make out the predictions, right? So this may work when you have your image sizes as very low resolution, right? So this neural network may perform, right? But at the same time, when it comes to high resolution images, right? Let's say consider the megapixel images with big size, and let's say you have all three channels, red channel, green channel, blue channel, then this may be a problem, right? So the architecture performs a better fitting to the image data set due to the reduction in the number of parameters involved and reusability of weights. So CNN can be trained to understand the sophistication of the image in a better way, right? So why we need to step into the CNN? Because there is a case where image is not just a 3x3 pixel, right? It is going to have some color channels, for example listed here, right? So red, green and blue. So in an image, there are three properties which you need to understand. The first one is the height, which you can see. Then the width, right? So height and width is always in the pixel, and the depth is represented by these color channels. So we don't have only red, green, blue as the color channel. We even have some other spaces in which you can represent the image. So you got a grayscale, you got HSV, right? CMYK, and there are many other channels available in the industry. So an image is not just a very basic matrix. It is going to be represented as array of arrays, right? So we got three different channels here. So we got convolutional neural networks to work on image processing instead of neural networks because their accuracy and precision will fall when the image will increase in its size, right? So computationally, things would get intensive, and kind of calculation of the weights and updating them again and again is going to be very much difficult when images they go really high in dimensions. For example, an image with the resolution 768043320, right? So computationally, your neural network's gonna take a lot of time. At the same time, right, it may or may not be the correct result which we are expecting from the neural network. Now, the role of the convolutional net is to reduce the images into a form which is easier to process. So mathematically, your larger image is first of all reduced into a smaller image, right? But here we don't lose the features, but we don't lose those features which are critical for getting a good prediction. Let's say there is a wall. On the wall, you have one, let's say, a painting. So we don't want to come up and understand, okay, that this is the wall. We want to target something known as the painting on the wall, right? So the entire wall is empty. So CNN is gonna make it more easier for us to extract that painting from that wall. Okay. So we are not going to lose features which are critical, right? And hence we can come up with a good prediction. So let us see how your CNN will work, right? So consider an image, right? So we are going to consider the image as 5 cross 5 cross 1 matrix. So to make you guys understand how the CNN works, we're gonna take it in a more easier approach. Okay. So 5 is the height, then 5 is the breadth, and 1 is the number of channels, right? So we're considering, okay, there is only one channel in this image. So we got this, bits. So it means what? So you have converted your image into the ones and zeros bit pattern. So how it can be done? It's very simple. If the RGB is your image channel, so the maximum value is 255, right? From 0 to 255. So we divide the entire value by 255. So once again, I'll put up in this way. So let's say there is some value called 244, right? So this is your red representation. This is the green representation. And this is the blue representation. So what we can do is, this is your image with 3 channels. So to convert image into ones and zeros, so always remember, right? So neural networks perform best when we have the data as fuzzy. So when I say fuzzy, so you need to understand your data is typically in the range of 0 to 1. All right. So what we can do is we can divide these values by 255. Okay. So RGB channel. So RGB values can be in the range of 0 to 255. So divide the value by 255 to get the result. So it's very simple for us how we can get the result, right? So it's gonna be all zeros for us, right? So we won't be able to divide any element by 255. But of course, yes, if this is going to be 255, right? So now after division, so the value would have been 1 and the 0 and the 0. Of course, there may be some other values, 0 dot and some XX, maybe some YY, right? Guys, can I get a smiley? Did you understand what we just discussed here? I hope this part is clear to everyone. So our understanding on the convolutional neural network is what, right? So typically we consider the channel, but here we have taken up this point that, okay, so all of the values are ones and zeros. So why ones and zeros are being considered? There is a reason to it now. Now moving ahead, so this is your image. So in CNN, the very first thing which you need to know is the kernel. So there is a function called the kernel function, right? And kernel will have a size. For example, here if you see, it's a 3x3 matrix, and it's like 101, 010, and 101, right? Now this is also referred to as a filter. Okay, so kernel is also referred to as a filter. So what we do is we do a mathematical convolutional operation on the image with this filter. Let us see how. So if you see this highlighted part in the image, right? So this is one part of your image. So as I said, the CNN is going to work in a way that it's going to extract features from your images. Now we are considering this matrix from a bigger matrix, right? So this is the part of your image. So we take a convolution with your kernel function. So what is that now? So 1 multiplied by 1 is 1, plus 1 multiplied by 0, plus 1 multiplied by 1, then plus 0 into 0, 1 into 1, 1 into 0, 0 into 1, 0 into 0, and 1 into 1. So that brings out to me as 4. You sum up all, right? So that's like your convolutional layer which is being formed. So your matrix gets multiplied by the kernel, and the shape of your convolved layer is the shape of your kernel. So guys, is the convolutional operation clear? So how it is going to work? Can I get a smiley as an acknowledgement from all of you? So this one got multiplied by this one. So I'll try to use this. So this one got multiplied by this one. Then you multiply this with the 0, this with the 1, then 0, 1, and this 0. So this is all multiplying, right? So when you multiplied all of them, finally you add them. And what you will get is this result. So I hope this is clear to everyone, guys. An acknowledgement waited. So what is convolution? Mathematical function, right? Okay, so moving now to the further part here. So what we are going to do is we are going to kind of, take the same pattern and move ahead. Now what we'll do is we'll go with the stride length of 1. When I say stride, it means that you now shift your array to 1 on the right. So here is this new, you can say, feature which we are going to take the convolution with the kernel, and you'll get the another value. So we keep on rotating this matrix, right? So on and so forth. We'll keep on rotating this fellow, and once you move on to all the iterations, you will get 9 iterations in total, right? So this is the second shift. Then this block will become the next shift. Let me highlight that part here. So this will become the next part, right? And then we'll move below in this part. Then we'll move here. So on and so forth. We'll keep on sliding, and we'll get these 9 different components here. Can I get a smiley once again from all of you? Did you understand what is the meaning of 9 iterations here? So how the iterations will go as 9. So we are basically sliding your image with a stride length of 1, and we are getting these to be convolved with the kernel and get this convolved here. Now, in a convolutional neural network, this is the very first step, right? So we are going to implement convolutional model where your image, which is a matrix of pixels converted into some ones and zeros, will be meeting with a kernel function to get a convolved layer. Let us take one more example here, okay? So this is where we are going to create one depth channel, which is your convoluted feature output. Now here, if you see, so what we got is, we got the input channel 1 as red, the input channel 2 as green, and the input channel 3 as blue. So we decided three different kernel functions, and every kernel function will generate an output. So we add these outputs and we create another output, right? So in the CNN model, so when you have these multiple channels, so of course you'll be dealing with multiple kernel functions. So every kernel function is going to yield a result. Now, for example, having this particular image set here, so when it will be convolved with the kernel layer here, so it will produce one result, the red result. Then same way you will get a green result, and then you will get a blue result. So when you have channels, so we're gonna add them up, and if there is supposed to be a bias, let's say the value 1, you add it and you put up the data in the output array. So guys, I hope this part is clear to everyone, right? So if you have multiple channels, right, so we have the ways to go ahead with it. Now the next part is the pooling layer. So after the convolution, we need to come up and do this pooling. So what is meant by pooling, right? Yes, Shimpa, so size of the kernel layer is fixed by us. So we fix the size of the kernel layer, okay? So we are the one who is going to fix the size of the kernel layer. So typically it is 3 cross 3. So in most of the models, we use the size as 3 cross 3. And yes, here, while we will be creating this model, so they will also see one more part here, that we don't use kind of neurons here. We will not be choosing a perceptron model. Here it's gonna be something where we'll be working on the kernels. How many kernel functions you would like to go with? So moving back to pooling layer now. So guys, pooling layer is responsible to reduce the spatial size of the convolved feature, right? So let us say your convolved feature was of the size of 4 cross 4. Let us assume that. So here what's going to happen? Your pooling layer is going to convert into 2 cross 2. Just an example here, right? So why is it so? Because we want that the data to be computed should be reduced. So it is going to act as a technique called dimensionality reduction. If you can remember, in our sklearn, we did this topic called dimensionality reduction. So we are going to reduce the dimension so that the computation becomes more faster, more easier, and more optimized. Okay. And at the same time, this pooling layer is going to extract the dominating features from your convolved layer. Now we are going to have this pooling with two different ways, either the max pooling or the average pooling. In order to understand what is max pooling, so we are going to have our image, sorry, convoluted layer. So in the convoluted layer, if you can see here, it's a 4 cross 4 convoluted layer. So what we will be doing is we'll be picking up the maximum value from the portion of the image covered by the kernel. So this is your first portion. So the maximum number is 20. Second portion 30. Then the third portion 112. Then the 37 as the last. So this becomes your pooling layer, and this is the final outcome which we are going to expect. So if it is going to be the average. So what we are going to do is we are going to take the average of all four, right? So 37 plus 4 plus 25 plus 12 divide by 4. So for example, 30 plus 2 plus 0 plus 0, 32 divide by 4, it's gonna be 8. So good to go, guys. So Shashi, there is again a mathematical part behind that how you're gonna come up with the kernel layer, right? So this is a very high level presentation on what is a CNN, right? The mathematical presentation is not discussed here, right? So for that, I'm gonna share the other documentation with you people. So guys, finally, let us now try to understand what's gonna happen. Okay. So there will be some input image, and you're gonna have some convolution on it. Then you're gonna implement some pooling on it, right? So after you have done everything, your pooled layer result will be flattened, will flatten the pooled result, and thereafter we train our neural network. It means that your neural network is going to be a part of convolutional network itself, but in the convolutional network we do two extra things before we feed the data to the neural net. The first thing is convolution, second thing is the pooling, right? So after the pooling, you get this data which will flatten. So what we are trying to say is we'll flatten this data 13, 8, 79, 20. So this 2 cross 2 is going to be your 4 cross 1. And once we achieve that, we feed that to the neural network. So the output nodes, they may work on the softmax layer to predict the classes. Okay. So this is how it's gonna be with respect to your neural network added into the convolutional network. So how is the final network going to be for us? So there will be input image. So the kernel function will keep on working on parts of images, right? So after the convolution, you get the pooling layer. Now we can even further do the convolution and pooling as many as times we want. So that's like your hidden layers in the convolutional neural network. Thereafter, the final output is shared to your neural network, which is going to flatten the data. Then gonna feed forward the data to the fully connected neurons, and finally we have an output layer with the softmax. It's gonna do a prediction. Let me show you one more image on the same. So here we are. So there's a handwritten image called 2. So the input size is 28 by 28 by 1. So there is only one color channel which is used, right? So we are not using 3 color channels. It's a black and white. It's a grayscale image. So it's one color channel with ones and zeros. So we got 5 cross 5 kernel. And I would be giving you one more thing here. So there is something known as padding when it comes to the kernel, right? So do explore that. Okay. So padding in kernel function. Please explore this. It's very simple, and you will be able to understand it. So 5 cross 5 is the kernel, and there may be some you can say n number of, right, kernels, if you can see here. So there are so many kernel functions which we are going to apply, and we're going to get some outputs here. So after this, you get the max pooling. Let's say the size is 2 cross 2. You got a max pooling. Now what you are doing is, so you are further again applying the convolution with the 5 cross 5 kernel on this fellow, and thereafter from the max pooling you again get some result, right? So guys, here this final result is flattened and is fed into a neural network, which is going to give you the outputs whether the handwritten image is 0 or 9. So this is the typical way your convolutional neural network is going to work. So now what we're going to see is we're going to see are very basic high level of CNN understanding, where we'll take the reference of TensorFlow and we'll explore one of the tutorials. Okay, so let us see what is that. So this is the tutorial which we are going to explore in our PyCharm today. Let's write a new Python file, session number 65. So CNN tutorial from TensorFlow, right? So we are not going to explore this tutorial on our data sets. We are just going to explore this tutorial from the TensorFlow web application here. So yes, Neha, you will come to know about it very soon. Let's explore this data set and you will understand how the things are going to work for us. Okay. So guys, the first thing first is that we need to have our TensorFlow imported, right? So import TensorFlow. From TensorFlow.keras will import datasets, layers, models, and there is this matplot lib to plot some image or maybe some graph. Okay, that's like the first thing first. CIFAR 10 dataset. So this is basically a Canadian institution for research, for advanced research. So they created this data set, right? So CIFAR 10 and CIFAR 100 are labeled subsets of the 80 million tiny images dataset. So if you see now in the CIFAR 10 dataset, so there are 10 random images. So there is image of an airplane. So all these images, they will represent an airplane somewhere here and there. In the automobile section, we'll see some vehicle. Then in the bird, we'll see some bird. Then same way we have cat, deer, dog, frog, horse, ship, and truck. So this is a data set representing 10 different classes based on your images, right? So here we got 60,000 images with the 32 cross 32 size. They are colored images. It means that you got RGB values. Okay. Now, out of these 60,000 images, 50,000 are for the training purpose and 10,000 are for the testing purpose. So what we're gonna do is we're gonna use this same data set and we're gonna understand what is the convolutional neural network, how we can create it, and how we can kind of calculate the accuracy when we have trained this model. Okay, so let's see that. So coming here to the TensorFlow tutorial. So the first thing is that you load this data set and you normalize the pixel values between 0 and 1. So what I'm gonna do is, so here we are. So train images, train labels, test images, and test labels. So guys, we can get these values by saying datasets.cifar10.load underscore data. So these datasets are going to be imported from the TensorFlow keras module, right? And the load data function is going to download the CIFAR data for you. So this data set will be downloaded first if not available in the system. So thereafter what we are doing is we are just saying the train images and the test images should be divided by 255 so that we get the data between 0 and 1, right? So let us try to say print the train images and print the train labels. So let's run this program now. So this will of course take a lot of time in a way, because this is somehow 60,000 images, right? So here we are, right? So every image is going to be a collection of this red, green, and blue. And overall, one image is going to be 32 by 32. So what I'll do is I'll just get these train images of 0 and train labels of 0. Let's try to run this program now. So this loading the data set, right, is going to take some time because it's a huge data set. So here we are, right, guys. This is a 32 cross 32 image, and this is the label coming as 6. So the 0th index image is somewhat representing 0, 1, 2, 3, 4, 5, 6, maybe the frog. Okay. But if you want to explore the data set, let us try to see what is the data set. So here they got another program. So I'll just use the same. So we're just exploring this tutorial from the TensorFlow only. So you got these class names: airplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck. 0 to 9, right? 10 classes. 0 to 9. So next is what we got, this plot.figure. The size is 10 cross 10. All right, and thereafter we have this loop for I in range 25. So loop's gonna run 25 times from 0 to 24. So we are creating a subplot of 5 cross 5, and the location is gonna start from 1, right? So there is nothing to be presented on x text and nothing to be presented on y text. So we are making sure that the x and the y has nothing. Grid is also false. By default also it is going to be false. So you are showing the image. The training images of I, that is like of 0, 1, 2, 3, so on and so forth up to 24, right? So you're using the color map binary, and on the x label we are going to put this training labels of ith indexes 0 value, right? You're going to choose this class name. So let me now run this program, and we'll see what is the data set. We're exploring the data set, the CIFAR 10 data set. We're exploring that. So here we are, guys. So we are trying to explore this data set, and what we see is these 25 images, if you can see, right? So frog, truck, then again truck, then the deer, then the automobile. So we want to train our model with these images, but these images are quite low resolution, if you can see now, right? So they are 32 by 32 with the RGB channel. So guys, till here, can I get an acknowledgement? Is the code clear to everyone? Anyone finding any challenge till here, right? So you are going to work on image classification. I hope you are able to understand where we are going with the convolutional neural network, right? So you are understanding, okay, that there may be different people with the different faces. So now you are going to come up and tell, okay, this face belongs to this person, right? So you are going to step into that part. All right, so let's move ahead next with the CNN approach here. Now, the next part is you need to create a model, CNN model. So in order to create the CNN model, we know that our input size is going to be 32 by 32 by 3, as in the image, right? So your image here is 32 by 32 by 3, okay? And we are going to first of all have this model called sequential. In the sequential, I am going to add a layer called convolutional 2D. The first 32 represents the number of kernel functions. So there will be 32 kernel functions which will be chosen automatically by this object of convolutional 2D. We don't need to worry about what will be the values in the kernel, right? That we don't worry about. So we are deciding that the shape is going to be 3 cross 3 for the kernel. So there will be 32 kernel functions. There will be 3 cross 3 shape of your kernel function. So this is the tuple. This first tuple here is going to represent what are the number of filters, to be precise, 32 filters, and the shape of the particular filter. Now, typically in the convolutional neural network, these filters are in the powers of 2. So 2 power. You may start from 2, you may start thereafter you go into 4, then 8, then 16, then 32, then 64, right? But what happens is when we move after the first layer, so your filters should increase, they should not decrease. Okay. So what we are trying to understand, let's see here. So I'm just going to remove this code here. So I think we are clear with the data set part, how the data set is. In convolutional neural network, we put number of filters in the power of 2, and as layers increase, we increase filters, right? So this is a general standard which we need to when we create a convolutional neural network. So there is this first layer, the activation function is ReLU. So we understand what rectified linear unit is going to do for us. It's only going to give us the positive values, not the negative values. So input shape is 32 by 32 by 3. So the max pooling layer is again a 2D layer, which is the size, which is a shape 2 cross 2. Then we added another convolutional layer with the 64 filters, and this is again the same. Then again added the max pooling 2D. Then you can again add, again go ahead, so on and so forth, right? Now, the more number of layers you are going to add for the convolution and the max pooling, the more better the result you are going to achieve. That is the only one theory. Okay. So lastly, what we do is we flatten the data, and thereafter we add one dense layer. So lastly, you have this layer which will do the predictions for 10 different classes, right? So we get these 10 different classes. So let's try to create this model here. So today we are going to see this code walkthrough from the TensorFlow tutorial, and tomorrow we're going to take our own data set where we'll be exploring our convolutional neural networks. Okay. So thereafter also I'm going to have this flatten, then the dense, and then the dense, right? So this is how you got this model. So add the convolutional 2D layer, max pooling, con 2D, max pooling, con 2D. Finally, you flatten the data. You put a dense layer. That's like your neural network layer. And then finally, you put a dense layer, which is the output layer, right? So this is your final output layer with 10 results, right? So guys, moving ahead now. So you want to train the model, right? So this is just like creating the model. This is creation of convolutional model, and this is further adding the neural net in Conv Net model. So you always flatten the data and then you proceed, right? So the next part is where you compile the model and you train the model, right? So this is the same story which we have been doing. So you compile the model, optimizer is Adam, the loss function is going to be this sparse categorical loss entropy, and matrix is the accuracy. So you fit the model, you have this training images, right? The training labels and the epochs. and we are going to write this validation data, which is test images and the test labels. So this will automatically even validate uh, train the model for this validation data, which is test images and the test labels. So you get a history, right? So we'll always get the history object, but what I'm gonna do is from the model we are just going to somehow come here and evaluate from the test images and the test label what is the loss and what is the accuracy on the testing data set, right? So I'm just gonna say print test accuracy. This is going to be final test accuracy, right? Comma this test accuracy. So we have explored this TensorFlow tutorial of CIFAR 10 dataset, right? And we'll now try to run the program. So there are 10 epochs. It's gonna take time, right? Depending upon your system, how it's gonna be. So when I will run this program, so you need to be a bit, on a waiting state, because this processing will take time when it comes to the 10 epochs, because it's a big model and it's gonna be 50,000 samples, right? Now this is the very first epoch on which we are working, guys. So there are 50,000 samples, right? So they're getting trained up, and with every training, right, we started with some losses and we are going with this accuracy to go up. If you can see here, right? So as in the samples, they are getting increased, right? So accuracy is increasing. So these are 10 epochs, right? So if you have more epochs, so it means it's gonna run down to more accuracy and it's gonna give you a more better result, right? So till time this model is getting trained, right? What you can see is, so there is this plot which has been plotted against accuracy and the validation. Okay, so if you want, you can just do this small plotting here. So what is the accuracy for the training data and for the validation data? So training data accuracy was increasing with number of epochs, and this was the validation accuracy, quite nearly matching this part, and the overall accuracy on the testing was 70%, which is quite good, not bad, right? Quite good. So guys, this is one of the tutorials which I have explored. So another tutorial which exploring yourself today is image classification. So this is the next tutorial. So we are waiting for our TensorFlow to finish off the training, and we'll be just able to see what is the accuracy. We're not working on predictions as of now. Now this is cats and dogs data set. Okay, so there are only two images, two classes, cat and dog. So these images are supposed to be trained with the convolutional neural network. So cats and dogs data set, if you see, right? So here we are with this model called sequential, which has been created. So you need to compile the model, and thereafter you need to validate your training and the testing losses, and finally you need to make the predictions, right? Whether the images are correctly predicted or not. Okay, so this link is already available on the TensorFlow tutorials. So I'll just share this link here. So please see, explore cats and dogs image classification problem. So this is just the beginning of the CNN, guys, and you have just seen a very quick introduction to what CNN is and how we can work with it, right? And we have a long way to go ahead with it. In the meanwhile, we are training our model. So you get this machine learning glossary. So many times you guys will face challenge, okay, that I came across this term and I am unable to understand what is this term. So Google created this machine learning glossary from A till the Z, whatever the words can come. For example, convolution, convolutional filter, the convolutional layer. So the same story which we discussed here, guys, right? If you see now, right, so how it will keep on advancing, and this small GIF image, right? So how the filter is gonna work. So I'll share this glossary for your reference. I'm gonna put up in the notes here. And I have this complete guide to your convolutional neural network, right, which is where some of you might be in a way of it, that okay, what is supposed to be the mathematical part here. Okay, so guys, this is one small ebook where we have this convolutional arithmetic, right, and how this all mathematics of choosing the kernel thing here and there goes. So this is an ebook of somewhere around 29-30 pages, so you can just go with it. So I'll be sharing this ebook over the WhatsApp group. Okay, so let us see how much we are in our training part. So what you see is that the accuracy has gone up to 67%, right? So you're very close by. So now in case your system is slow, so this may take up more time than expected, right? And other than this, guys, you can always use Google Colabs. Okay, so if TensorFlow is not supported in your system, you can use Google Colabs. Now I can write the same program with the Flask as well. So I can create a user interface. I can click on a button and I can say create model. So when I will say click, this code will be executed. Then I can say compile model. Then I can say train model. And finally I can say show me accuracy. Correct? So you can design this model over the Flask if you want. Correct? So I will be doing the same, but not on these data sets. These are just the tutorial data sets so that you guys can explore, okay, how we can create a model with the convolutional approach. So I'll be exploring the data set tomorrow for some x-ray images, where we are going to work on this COVID viral infection data sets. So I've been working on a few of the data sets to get the chest X-ray with the COVID-19 patients. So once I am through with that, we'll be able to create our very basic project. So this accuracy has gone up by 71%. If you can see, this is, I think, the 5th or 6th epoch. So in the meanwhile, if you have any queries, guys, please raise the same, because this will take I think a couple of more minutes to finish. So in the meanwhile, you can please raise your queries. Okay, Pradeep says, what is the meaning of flatten? So Pradeep, let us assume that you got this image as in 101. So zeros, 1, 1, and 1, 1, and 1. So let us assume that this is a 3 cross 3 image. Okay. So flattening this image will be what? Flattening this image will be 1, 0, 1, 0, 1, 1, 1, 1, and 1. So what this became? This became 9 cross 1. This is known as flattening of the image, Pradeep. Good to go? All right. So guys, any other queries can be please raised with respect to convolutional neural networks, right? So we need not to work much mathematical when it comes to your, what should be the kernel function, what should be the value in the kernel function. That will be taken care automatically by these APIs. So we highly rely on the APIs. So it's the 8th epoch. We are very much close to finishing. So accuracy up by 75%. So there is one more data set. If you want to explore, I can write that. So this is one cats and dogs image classification. I'll just put this as homework. The another one maybe the handwritten image data set, right? So identifying what exactly is the handwritten image when you give it as an input. Now, based on these image classifications, you can come up with so many project ideas, guys. Very basic project idea is like what? Which plant is what, right? For example, you have 10 different plants. So if I take an image of that particular plant, I should be able to tell, okay, that this plant is this thing. And then you can list down that this plant will have these many problems. These are the seasons for this plant to bloom or to blossom, right? These are the insects which will be attacking this plant. Just for an example, right? One of the ideas. Same way, when it comes to the chest X-rays, we'll be able to kind of, detect the diseases and would be able to predict and tell, okay, that this medication should be followed or this kind of course should be taken care of. So, guys, this is the training accuracy. If you see, the training accuracy is up by 77%. So, Shashi, for images, you always need to work on CNN. The problems like regression and classification on the numerical data is taken care by neural networks. But when it comes to image classification, so then you need to rely only on CNN. So it's just a simple decision, right? So before this, what we have been seeing was the CSV data sets, if you can recall, right? The CSV data sets were all these numbered values. But here you have images, RGB values. So image classification to be taken care by the CNNs. The regular data classification or data regression, you use the ANN. So in your project works, you guys should not be using ML models. You guys strictly should be working on ANN models, guys. Now this training can be costly, right? If the number of epochs are even beyond 10, right? So if I want to achieve a very good accuracy, right? So this has to go up, let's say some 15 or some 20 pokes. At the same time, you even need to do some hit and trial to see how the accuracy can go up. You may decide to use more filters here, then some more filters here. Maybe you start from 64, then you go to 128. So it's all a kind of hit and trial which you need to work on, guys. So finally, guys, you have this accuracy of 77%, right? And the test accuracy is 70.3%. Not a bad accuracy on the data set, right? So this is one quick introduction. What is the convolutional neural network, right? And for the convolutional neural network, we need to work on images rather than the basic data as answered previously. So now you need to explore these two data sets and try to write convolutional neural networks. So you can always use Google Colabs in case your TensorFlow is not supported. But of course, yes, if it is, then make sure that it will take time to train the model. It depends upon your processor and the machine configuration. So this will be all for the day, guys. And tomorrow we're gonna write some Flask app. Then we're gonna work on some chest X-ray images. We're gonna write some convolutional neural network, and similarly, we'll be taking few more examples with the same approach from where you will get some more ideas on your project work. Okay. So this is all for the day from my side. Thank you so very much. Once again, this is Ishant on behalf of Auribises. I hope you all have a good time, good day, happy coding, and guys, do make the best time for your career path. Do not skip this programming exercises. Okay, don't think that okay, I'll review the session on the videos and it will be done for me. So till time you don't code, you don't get. Thank you. See ya tomorrow once again with the new CNN application. Bye bye, guys.